So now we're going to look at the ratio and root test. And these tests are pretty straightforward to apply. Sometimes, a lot of times though, what will happen is you'll find that they're not useful. They won't give you the right answer, or they won't give you anything useful. So it's inconclusive. So what you need to look at is the whole point is I'm going to take the limit as n goes to infinity of the absolute value of the next term in the sequence. It's 2 over n plus 1, 2 over n plus 1 factorial, all divided by the nth term, like this. Now, these are always positive numbers, so I can get rid of the absolute value signs. So this is going to be 2n plus 1 over n plus 1 factorial. Dividing my fraction, I multiply by the reciprocal, so it's n factorial over 2n. And you want to do some cancellation now. When you see factorials, you're almost always going to use the ratio test. And because one thing that's nice is the factorials cancel. Like, I can't do things like integral tests, right? Because I don't know how to integrate when there's a factorial, right? That's like really hard to understand. So this will cancel. Because n factorial over n plus 1 factorial is just n plus 1. So the factorials go away, like that. And then the 2's here are going to cancel. And so this is the limit as n goes to infinity of n plus 1 over n plus 1 times n. Now the n plus 1's are going to cancel. And I just have 1 over n, right? And as n goes to infinity over 1 over n, this goes to 0. And that's what I need. I need to go to 0. And that tells me it converges. So as long as the ratio goes to 0, it converges. If it goes to infinity, it diverges. And if it's in between, then it's inconclusive. Okay. So again, we're going to do the ratio test. Limit n goes to infinity. I tend to shortcut this because you're going to do n plus 1 over n. So I really write this as n plus 1 factorial, 10 to the n plus 1 over 2 times, if I plug n plus 1 here, it's going to be 2n plus 1 factorial. And then I multiply by just this whole thing flipped, right? Because I'm going to divide by, this is the a n plus 1 term, this is the a n term, just flipped, right? So now we're going to do a little bit of canceling, but I want to be a little bit careful, especially when it comes to this part here. This is 2n plus 2 factorial, so let me write it all out again. And then a lot of nice stuff is going to cancel. So first of all, 10 to the n plus 1 over 10 to the n is just 10. Did I leave out n factorial? N plus 1 factorial over n factorial is just n plus 1. This one's a little tricky. There's actually 2 terms left down here, 2n plus 2 and 2n plus 1. That will cancel with that. So I really get limit n goes to infinity. I'm going to have an n plus 1 still here. I'm going to have a 10. And then on the denominator, I'm going to have a 2n plus 2 and a 2n plus 1. Because this is really 2n plus 2 times 2n plus 1 times 2n times 2n minus 1, etc. And then this is 2n times 2n minus 1, etc. And that will cancel. Everything except the top 2 terms are going to cancel. And if I FOIL this out, or just look at the dominant term, this is going to be 10n plus 10. This is going to be 4n squared, plus a bunch of other stuff that are lower powers of n. And see, this is going to be bigger. This is n squared. This is just n. This is going to be 0. So it converges. Okay. Thanks for watching. If you enjoyed this video, I go through a lot more of these exact kinds of problems with much longer videos on my website. It's entirely free. Check out the link in the description below.